The last video in this topic of other graphs is the logarithm graph. Now, the logarithm is a different way of dealing with big numbers and powers. You won't formally learn about logarithms in Year 10. In Year 11 methods, we certainly will learn about logarithms and their properties in Year 10. We just want to recognise there are graphs of logarithms, and they actually occur naturally in science. A lot of things in real life are modelled by the logarithm graph, so it's important we investigate them. Here's the basic logarithm graph. We've decided to make A1 and the base number 2. So we read this as y equals 1 times, forget about the 1 because it's optional, so y equals log to the base 2 of x. So the base number 2, we say it's log of base 2 of x. The table of values shows all these points on the graph here. Probably the one key point of the logarithm graph is log of 1 equals 0. Log of 1 equals 0. So you see the graph has an x-intercept and does not have a y-intercept. So, and you notice the graph only exists on the positive values of x. We can't have negative values of x into this rule. We now also have one of these asymptotes. That means the graph, as we get very close to 0 for x, the y value starts approaching negative infinity, but will never ever touch that line. So you have a look at the table of values there. We've got a couple 0.25, so s plus 1, and the log of that is log base 2 of 0.25 makes negative 2. Okay, let's see what happens when we change the base number. Let's make the base number bigger. Let's have a look at log to the base 3 of x. Don't know if you noticed that. We'll go back to 2, then make it 3. The graph on this side actually came down close to the x-axis, and on this side here it actually also, you would say, got close to the x-axis. So as I increase the base number, so my base of 5, you can see the graph is getting dragged towards the x-axis, getting closer and closer. So the top base number I've got on this little applet is 10. Here's the graph of log 10, log of base 10 of x, and you can see still has the x-intercept of 1, 0, so all logs of 1 equals 0. But as I put a bigger base number in, the y value tracks the graph towards the x-axis in both directions. So it approaches this line, this asymptote down here, a bit quicker, the bigger the base. So as I slowly change the base number back to a smaller number, you see the graph is now getting further away from the x-axis for the same x value. Okay. One of the things on your workbook says make the base e. Well, I haven't allowed this program to do it. Base e is a number somewhere between 2 and 3, so the graph would sit between those two. Still has the same x-intercept, still has a vertical asymptote at x equals 0, but its base e is closer to 3 than 2, but it sits between those two graphs. An important graph in mathematics. Okay. The next obvious thing is to change the value of a. Shouldn't be any prizes at this point to know that a stretches the graph away from the x-axis, so bigger the a value, it will stretch it away. So here we're looking at changing the a value. I've made the base 3, and if I make it 4, you see each x value is now 4. For each x value, the y value is 4 times higher. You'll notice here base 3, when I put 3 into the rule, the answer is 1. So 4 times log of base 3 becomes 0.34. So just to show that if I make the base 5, you'll notice here the point 5, I've got x in it's 5, 1. So if you have the same number as the base number, it'll equal 1. So log 7 of 7 equals 1. Let's go back to our base 3. So as a gets bigger, we just stretch it, dilates from the x-axis. So if we make an a bigger, it stretches it from the x-axis by that factor. If I make a half, it stretches it back towards the x-axis by a factor of a half. Similar change in the base. So all these values are half the original value, which is on the dotted red group. And the last thing to investigate is to make a negative. So let's put one on the notes is base 4. So we'll do that. And once again, making a negative, it flips the graph over the x-axis. The x-intercept here, 1, 0, is still 1, 0 because it's on the mirror line, so it doesn't move. But you can see the point here, 4, 1, now becomes 4, negative 1. X equals a quarter was negative 1, and when it's flipped over the x-axis, a quarter, positive 1. If we make a more negative, it's still reflected and just stretched away from the x-axis by that factor. And the last thing to consider is if it's less than 1 but still negative, it does the same as when it's positive a half, stretches it towards the x-axis, but because it's negative, it's still reflected about the x-axis. I think that covers logarithm graphs. You need to now complete the worksheet and the questions from the work plan. Thank you.